So we are still working on our tooling and make it more pretty for us so that we can work easier with stuff. And you might already wonder a lot how we can create those. Let me see where they are. I think they are animations, many. No, where are they? Detail blueprints? No, that's what we created. Blueprints. I think it's in rigs. Yes. So that's the retargeting. And where is this IK mannequin? So it's here basically. And this is the IK rig which we need to configure. And you see here it has a lot of chain names. And you cannot click them, multiple of them, and do copy or sort. You can just say sort chains. And it's really annoying that when you create them, you need to click here, then select the bone and so on, and that's that's a lot of pain. And you can also not migrate it to another one or so. And yeah, I really miss that feature, the new tooling. And it might be very time consuming to create those chains because you have to click them individually every time. And what we will do in this part of the series is how we can use Blutilities to improve our workflow or to speed it up basically. And if you have a lot of characters, you don't want to create all those chains manually. There should be a way to create them. Also for the settings here or so, that's what we will not cover in the session. Maybe in the future. I did not dive yet into the public API, how we can get the data and so on, because sadly that's not exposed to blueprints, and I did not found yet so far how we could use it in pure blueprint stuff. But as usual in this series, it's very easy to implement it in C++, just a few lines, and we will get very happy during creating IK chains. So let us really dive into the topic and we start working on stuff. So as usual, we create a new Blutility. So this time we will not have issues. Asset, action utility, and we call it IK rig hooks. Oh no, we call it not hooks. Oh, sadly, I did call it hooks. It's functions. Sorry. So as usual, we delete the parent class and search for IK rig. Is there IK rig? Body solver, and it's a lot of stuff. So I think it's definition. Let me quickly check. I already implemented this in another project, and to make sure that I don't miss anything. Supported class. Yeah, it's IK rig definition. That's what we need. And so how can we do it? Dump IK chains. That's one function we will implement in this session. And here it's called character, sadly, tools. And as usual, we say get selected assets for each loop. And we will move this to the left. And we say cast to IK rig definition. So let's compile and save and attach this window here and see if we already have our Blutility stuff. And yes, we have. So we can already call this here, and then it will dump the stuff to our clipboard, and we can use a data table here. And let me show you quickly that you can follow the stuff here. I already prepared something. This time you will not have to watch me how I get or how I implement the signatures. That's very boring. I think, for you. So what we need to change is the H file. I will also open it in Visual Studio that you can see what needs to be implemented. So we need a new struct, we need new functions, of course. I already introduced the signatures in the CPP file, and that's very important. Open the TT Toolbox build.cs file and add ikrig and ikrig editor. So let me show this you in Visual Studio. That's very important, otherwise we cannot get a successful build, because we now introduce a new dependency. So what we need to add here is this line, ikrig editor, in the private section, because we need to ask some, or we need to use some headers for this, so that we can get it properly working. And we need to add the public dependency ikrig here. And in the, so make it, stop the video here and type in the names. And here in the header file of TT Toolbox blueprint library, we introduced the new struct. That's this one here. So it basically contains the chain name, the start bone name, the end bone name, and the IK goal. The same settings we saw in the editor. Let me go back to the editor that you can see it. Here basically these are the chain name, start bone name, end bone name, IK goal. And let me go back to Visual Studio. So, and yeah, we expose this to Blueprint, say it's read and write, so that we can set those names, edit anywhere. And we also want to use a custom constructor here, so that we can use the f-bone chain, which is from the C++ world of the plugin, which is not exposed to blueprints. That's why we use this wrapper struct here, so that we can use it in both worlds, like in the C++ world and in the blueprint world. And furthermore, we need this header file here to get the dependency to this f-bone chain, and we need to forward declare these classes here, otherwise it will not work with the signatures here. So here's the ikrig definition, here's the function which we will implement quite soon, the dump ik chains. Then here we can add the ik bone chains, and we can set a bone chain goal. So, and here you can also stop the video, so implement these three functions. And let me make this a bit better here. And we go into the C++ file, there we have those functions here. And then you should already have a successful build. So let's check if this is really the case. If we build stuff here. So let's see if it works. So live coding works. So yeah, everything works as expected. And we can still continue now on our blueprint world. And for that, so it's a bit complex, so that on the other screen I'm looking what we need to implement, and then we go step by step and see what is going on. So here we need to expose this variable to a local variable, store it basically, not exposing it, and say ikrig definition, align everything. And then we need a sequence node. You should now know how this works. I don't repeat the shortcut here. And we will use a print string. And then append, of course, like always. I really like this node. And we will also not print it to the screen, uncheck it. And here we say quote, and we use the definition here, rig definition, and say get path name. So basically get a name here. If you select multiple ones, then you will get one line in the output log where we say, or where we get the full path to the asset. So this part here is done, nothing more to do. And here we can start implementing our new stuff. The dump ik chains. And for that, we will also use this local variable here, connected here, connected here. IK-rig definition, object reference not compatible. Why? IK-rig definition. IK-rig. That's weird. Dump IK chains. Oh, sorry. sorry guys. Sorry. It's the same name. Dump IK character tools. I think it's no, wait, I think I have an issue. Wait, let me close quickly the editor and also the other editor. I need to rebuild stuff here. I think something is wrong. Let me quickly build in Visual Studio. So the build is fine. Oh, sorry guys. Sorry. I used the wrong category. It should be TT Toolbox. So now the build is done. We will start again. So let me start both editors again. Might take some time. Sorry guys, I messed that up. Not properly prepared. But it happens if you do live coding sometimes. Even I struggle sometimes with coding. But as long as you know how to fix stuff, it's perfectly fine. So, yep, we're going to reopen the assets basically, and now we should be able to call our dump IK chains. Now it's the correct function. So, and let me quickly check if there is something missing to implement. So the dump IK chains. So yeah, as usual, I don't connect this pin here. If you want to raise an error message, you can still do it. But on the blueprint side, that's already done. And we will be happy, hopefully. So if we already try to run our function, like here, we should see something in the log. So yeah, here, that's the one. And let me clear the log again so that we can see it again more properly or more clearly. And here, yeah, we get the asset. So that's perfectly fine. And now we need to go into Visual Studio and implement the function, the custom function to dump those IK chains. So let me go into this function. And also let me check what needs to be implemented in the C++ side. At first, like usual, we check the input arguments. So, oops, check the input arguments. Then, yeah, we prepare the dump string. Iterate over all IK chains. And yeah, print the IK chains to the log and store the IK chains in the clipboard. So I think you might get already bored because that's very straightforward and yeah, it's very easy to implement if you know what functions need to be called. So if it is valid, we will do it. If it is not valid, we will return error message like usual. So copy this over, type in called dump IK chains with invalid IK rig definition. So and then we return false. And here we let's also return an error message called done by kchain with IK rig definition, which did not provide any IK chains. And for that we let's introduce this one, %s, comma, and we use, I hope this is still the case here as well. So where is the header file for this one? Object, okay, definition. I think we will have to include this one here as well. So go back to the top of the file, which provides a lot of includes. So that's how I do it all the time. It's IK rig definition, and we just say include here IK rig definition. So, and for that, is there, I think it's get called path name. I always forgot how to do this. Sorry guys. I think it's get full name. That's what we want to use. So where are we? We are here. No, we are here. And it's not the skeleton. It's the IK rig definition. So what I do all the time is use parentheses here correctly so that the code can be read very clearly. And now we start implementing our dump string. That's pretty straightforward. So we introduce a new string variable here. If we have more than one chain, we need to prepare the string for arrays basically. And that's what we do here. Then we implement the loop. So iterate all over them. Here we have a count variable where we count how many chains we already have covered, and then if it's greater than 0, we introduce a comma and then go on with the next chain, and then we store them. And I think here's an ampersand missing. And what we need to do as well is this one here. It's after the one. So if we have more than one IK chain, then we need to introduce a closing bracket. And then, as usual, we dump the string to the output log, and we also store it in the clipboard. And that should do our job. Let's see if it works. And we click here to trigger live coding to see if the build will be successful. So it seems to be the case. So let's clear the output log. And let's do a right click, dump IK chains. Oh, sorry, it's the output log. So we already have it here. That's amazing, right? So all the data we have to select and so on. Manually, we can now print to the console, or not to the console, to the output log. And what we can do now is very interesting. We can introduce a new data table. And we go to miscellaneous data table and search for, how was the struct called? I'm not good with remembering names. So it's f_bonechain underscore bp. Bone chain. Is there something missing? Blueprintable. Bone. Interesting. Wait, let me quickly check in the other project. So here's the other project. Maybe I'm too fast and I did not implement that yet. Then we need to stop the video here. So data, bond, IK rig settings. Notice here. I'm confused. Why does it not work? It should work. It should work. Let me also check the code here. That's blueprintable and so on. Normally it should work. Pick row structure. Bond chain. That's weird. Maybe I have a typo. So let's really use this one. Okay guys, we need to stop the video here, sadly, and I need to figure out what is going on, and then we will cover this in the next session. But so far you can already print those IK chains to the output log, and it would also be stored in the clipboard. What we can see if we open, for example, an editor here and press Ctrl V. No, it's not, sadly not. Sure, it's not, because I was using, so it gets even more worse. But as you see, it should work perfectly fine. And yeah, let's cover why the data tables not work in the next session. See you in the next video.